So in this lecture, we're going to multiply and divide rational expressions. The key to doing this is built on what we've already been doing. So when we multiply these things, okay, so we're going to, essentially what I like to do is add in parentheses to start. And then what you want to do is when you're multiplying, that's essentially it. You multiply the numerator, you multiply the denominator, and so now we have x squared minus 16 times x minus 5 divided by x squared minus 25 times x minus 4. So you just multiply numerators, multiply denominators. And now if you want to simplify this to lowest terms, we're just going to do what we've done before, which is factor the numerator as much as we can, factor the denominator as much as we can, and then reduce. So the numerator, this is a difference of squares, so this is x minus 4, x plus 4, and that x minus 5 stays there. And then we also have x squared minus 25, which is x minus 5 times x plus 5, difference of squares there, and the x minus 4. And then now this is fully factored, and we get some reduction. The x minus 4 is reduced, and the x minus 5 is reduced, and the x plus 4 is there, and the x plus 5 is there. No more reduction is taking place, and so this is our solution. So for our second example, we have this product. So 3x minus 12 divided by x squared minus 4, and then multiply by this rational expression. So multiplication, we're just going to multiply numerators and multiply denominators. And now let's proceed with factoring. So 3, we can factor that out, x minus 4. We can factor this trinomial. X, we need the product to be 8, the sum to be 6. So that would be plus 4 plus 2. Right, product is 8, sum is 6, so that looks good. Divided by difference of squares, so that's x minus 2, x plus 2, x minus 4. And now let's reduce. So the x minus 4 is reduced. X plus 4, there's nothing to reduce. X plus 2, we can reduce that. And we get our answer 3 times x plus 4 divided by x minus 2. Okay, moving on to our next example. So we have a product. So we are going to multiply numerators and denominators, right, separately. So multiply these numerators. Let's factor. So this one, we can't factor anything else out, so that's going to stay the same. This trinomial, by sort of trial and error, looking at these factors, right? We don't have anything constant-wise that we can factor out, but sort of by trial and error, looking at these factors, we'll have 2x and a 6x and a plus y and a minus 5y. It looks like that'll work. So 2x, so that'll be 12x squared, and then minus 5y, and then look at the middle term. So this will be minus 10xy, and then plus 6xy. So that'll give us the minus 4xy. So that looks good. And so this one we'll leave alone, but then by trial and error, for this one, similarly, thinking of the factors of 42 and 15, we get 6x and 7x minus 5y and plus 3y. And does that look good? So that'll be 42x squared, and then we'll have 18xy and then minus 35. Okay, so this looks good. Okay, and then 2x plus y. Now, does this reduce anymore? So the 7x plus 3y, we can reduce this, and the 2x plus y we can reduce, and the 6x minus 5y also looks like we can reduce. So surprisingly, all that stuff reduces, and we get 1 over 1, which is 1. Continuing on, looking at this. So now we're going to do division. Okay, so when you divide, the trick to convert this is change to multiplication by multiplying by the reciprocal. So how does that work? Well, you just take this first expression, the x squared minus 2x plus 1, divided by the 3x squared plus 7x minus 20, and then we just multiply by the reciprocal of the second one. So just flip the denominator and numerator. We have 3x squared minus 2x minus 5 divided by x squared plus 3x minus 4. And now we just sort of continue by factoring. You know what, let me actually leave some space here. So this will give us what? So factoring this, leading term is 1, so we're going to have x and x. We need the product to be 1, the difference, or sorry, the sum to be negative 2, so that'll be a minus and a minus, and minus 1 will work, right? So minus 1 minus 1. What about over here? So this is 3x and an x. That's the only way to get 3x. We need a minus 5 as the product for the ends here, and a minus 2. So the only way to get a minus 5 is a 5 and a 1. One of them is minus, one of them is plus, but I need to get a minus 2. So we will put the minus 5 here and the plus 1 here. And let's see if that works. So that'll be 3x minus 5x. So you add those, you get minus 2x. So that looks good. And continuing by factoring the denominator, we have another one where we have a 3x. So that'll be a 3x and an x in order to get 3x squared. And we need the product to be minus 20, but then we want the sum to end up as a positive 7. So that looks like, well, let's see. So 3x, so maybe 5 and 4. So what if we had minus 5 and a plus 4 here? Right? So what would that be? So that would give us 12x. And then minus 5x, so that'll be 7x. So that looks good. And the last one is leading coefficient of 1, so we have an x and an x. We need the product to be minus 4, sum to be positive 3. So minus means we have to have a minus and a plus. So minus and a plus. So to get a plus 3, let's put the larger one, the 4, and the 1 there. So that'll give us the correct factorization. Okay, and then now reduce. So the x minus 1 will reduce. We're still left with one other x minus 1, no reduction. 3x minus 5 reduces. And it looks like that is all that's going to reduce. So we're left with x minus 1, x plus 1. Denominator, we have x plus 4, x plus 4. But these two are the same, so you might as well write that as a square. So x minus 1, x plus 1, and then x plus 4 quantity squared. And that looks good. All right, so looking at our next example, we are doing multiplication again. So we will multiply numerators and then we will multiply denominators. And let's start to factor. So we have a 2x to the fourth minus 16x. So we can factor out a 2x out of this first factor, and we would be left with x cubed, and then minus 8. So we'll have to use the difference of cubes to factor that in just a second. And then what can we factor out of this? Well, we can factor out 6x cubed, and we'd be left with x squared, and then plus 4. Any x's left over? Well, we factored 3 of them out, so that's all that's left over. Okay, and then now what about down here? So we could factor out 3x squared, and we'd be left with x to the fourth, and then minus 16, and we already factored all the x's, so x to the fourth minus 16. And then what about this here? Well, we can factor out a 4x squared, and that will leave us with an x squared plus 2x, and then what? So 16x squared leaves us with plus 4. Okay, now let's try to factor what we have left over. So difference of cubes, we can factor that a little bit. We can factor this as, right, this is 2 cubed. So our formula for difference of cubes, this would be x minus 2, and then x squared plus 2x plus 4. And then this 6x cubed, x squared plus 4. We're not going to be able to factor this anymore. We can only factor if it's a difference of squares, right? 3x squared, but then here, this is a difference of squares. This is x squared plus 4 times x squared minus 4, right? This is x squared squared, and this is 4 squared. So that's why we would get this. We have 4x squared, and then x squared plus 2x plus 4. Okay, so there's a lot of reduction that's going on. So let's try to do this as carefully as we can. Let me use a color here. So let's see. Let's the 3 and this 3 reduce. You know what? I'm going to carry the x's and write them out, and then we'll reduce them a little bit, okay? So is there any x minus 2's? Oh, look, we can actually do a little bit more reducing here. Okay, well, you know what? Let's do that in a couple of steps. Sometimes it's better to do a couple of steps. So you see that this whole factor is right here, the x squared plus 2x plus 4, and then the x squared plus 4x squared plus 4. And we're going to be able to reduce a bunch of these x's. So you see, I could reduce, how many x's do we have in the bottom? We have x squared, so we have a total of 4 of them. And we have an x and x cubed, so we have a total of 4 upstairs as well. So those are all going to reduce. And 6 is 3 times 2, and then 2 times 2. So we're going to get a little bit of reduction here. Oh, you know what? Look back here. I actually just accidentally wrote 3 when I meant to write 2 there. So what was that? So that was a 2x. Okay, now switching back to red. So the 2 will reduce this. This is, okay, that's 2 times 3. Sorry, 2 times 2. 2 times 2. So that 2 will reduce one of those 2's. The 6 is 3 times 2. So this 2 will reduce this 2. And this 3 will reduce this 3. So we actually don't have any constant left, right? Okay, so this is what I was talking about, where it's a good idea sometimes to do this in several steps. So what do we have at least right now left over in the numerator? We have x minus 2. And anything else? So that's all we have so far. Denominator, we have x squared minus 4. And that 4 is also gone. Right, we reduced all its factors out. So what I was getting at here was that this actually reduces a little bit more, because that's a difference of squares still. So we have x minus 2 divided by x plus 2 times x minus 2. So the x minus 2's reduce, and we're left with 1 over x plus 2. Okay, continuing on. Now we have a product and then a division. So we're going to have to multiply by the reciprocal of this. So what do we have? You know what? Let's start to factor as we go along. So the numerator here, this will be we want the product to be positive 9b. So how will we get that to get a minus here? So probably going to have a minus for that to work out. And 3b should work, right? So that product will be positive 9b squared, but then this will be minus 6ab. So that looks good. What about this one? So this will be a. We want the product to be 6b squared, but then a minus for the sum. So we need a minus minus to make that positive and get the sums to be negative. The factors for 6 are, well, the ones that will give us a -5. Looks like it's going to be negative, wait a minute. So what would that be actually? Oh, 2 and 3. Sorry, 2 and 3. And we need b's in there. Okay, so now let's double check. So a squared, that's good. And then minus 2ab minus 3ab, so that'll be minus 5ab, and then plus 6b squared. Okay, that looks good. Then, okay, then we're going to have to multiply by the reciprocal. You know, switch that to a multiplication and then swap these two. So we'll actually have, you know what, let me just write that out. So we'll multiply by the reciprocal of this. So we'll have a squared minus ab minus 6b squared over the a squared minus 9b squared. Okay, so now that's multiplication, and we will multiply by the reciprocal of this. Can we factor what we have over here? We'll deal with factoring that in just a second, but what do we have over here? So we have a difference of squares, so that's a minus 2b, a plus 2b. This is already factored, actually, so a minus 3b, a minus 3b, that's squared. So then now we can factor what we have here. Maybe we should reduce some things while we go along first. So reducing, we can reduce a minus 3b, a minus 3b, a minus 3b, a minus 3b, a minus 2b, a minus 2b. Okay, and we have these two left over. So what is this last multiplication factor into? Okay, so what are we left with? Up here we have this a minus 3b, but then what is this factor to? So that'll be a. We want the product to be minus 6b, and the middle to be a minus, so we'll have to have a minus and a plus. To get this, it looks like we'll need a minus 3b and a plus 2b. So let's double check that. So that'll be minus 3ab plus 2ab to give us the minus ab, and then the minus 6b squared. Okay, that looks good. And then down here we still have the a plus 2b. And then here we have a difference of squares, which is a minus 3b, a plus 3b. Okay, then we should be able to reduce a little more. So the a minus 3b, a minus 3b, a minus 3b, there's no more. A plus 2b, there is one here. So a plus 2b, a plus 2b. And that looks like we finally get our answer, a minus 3b divided by a plus 3b. Okay, so our next example, it's just a multiplication, but it sort of looks like it's set up that factor by grouping might be a possibility here, because it's sort of, these terms are spread out in this way, and let's see if we could do factor by grouping. So we're going to multiply, so we'll multiply numerator, multiply denominator, denominator. So factor by grouping, I can factor out an x, and I'm left with a plus b. I can factor out a 2, and I'm left with a plus b. So that's this whole factor. And then here, what can I factor out of these two separately? So these two I can factor out an x, and I'm left with a minus b. Here we could factor out minus 3, and we're left with a minus b. Denominator, similarly, let's do a factor by grouping. We will factor out a, and we're left with x minus 3. We could factor out b, and we're left with x minus 3. Note, when you're doing this factor by grouping, you want the leftover factors to be the same so we can factor out even further. Here we have something that we can factor out x, so that's a minus b, and we can factor out a minus 2 to get the a minus b as well. Right? If we only factor out the 2, then it would be minus a plus b, but we want the a minus b. That's why we're factoring out that negative as well. And now we can factor a little bit more. Don't start reducing, right? Do not reduce until you have full factorization. Okay? Okay, so factoring a little bit more, a plus b out, we would be left with x plus 2. Factoring out a minus b over here. Right, so those are your square brackets, but we can actually drop those at this point. Factoring out a minus b, we're left with x minus 3. Then factoring out x minus 3, we're left with a plus b. Factoring out a minus b, we are left with x minus 2. And now these are all just normal, you could forget about those bracketed parentheses, right? And so we can start to reduce things. So let me switch to a different color. We have an a plus b. Do we have any a plus b's? Yes. Reduce a x plus 2. Any x plus 2's? No. A minus b's? Yes. X minus 3's? Yes. So it looks like our final answer is going to be x plus 2 over x minus 2. For our last example, we're going to use a similar strategy. We're multiplying. And let's see how much we can get from factor by grouping here. So let's do a factor by grouping and for that first one. So this first one, we will have, let me just use square brackets here because I'm going to have parentheses as well. So I can factor out an x squared, and we'd be left with x plus 2. And here we can factor out a minus 9, and we are left with x plus 2, which is good. So I can factor out that further. This cube, we have a common factor of x in all the terms. So I can factor the x out, and we're left with x squared plus 5x plus 6. And that's going to be a nice trinomial that we can factor. Down here, we have x to the 4th. We have an x squared, and an x. So we could factor out the x, and we're left with a cubic. It looks like we're probably going to be able to do factor by grouping there, actually. So maybe we should just start with that. So factor by grouping, x squared, we'd be left with x squared plus 3. Let's see if that works. We only know that it's going to work if we get that leftover factor. Here, let's see if we factor out minus 4x. What happens? So minus 4x, we would get a x, and then a plus, x, wait a second. Yeah, so this is not actually working out, right? Because we're not getting an x squared there. So just going back, let's change the tactic a little bit. Notice that we definitely actually had a common factor of x in all of these terms, so we can actually factor that out first. So let's factor out an x, and we'll have x cubed plus 3x minus 4x minus 12. Right, so reducing all the powers of x by 1 there. We'll have a cubic, and then we can attempt to do some kind of factor by grouping there. And then this right here is x, so the minus 6 and the minus x. We will need to do one of them is a minus, one of them is a plus. The factors should be minus 6 and a plus 1. Or wait, no, that's not right. So 2 and 3 will work, right? So minus 3 plus 2. Right, now the sum is minus 1, minus to give us the minus x, and the product is minus 6. Looking at this right here, I'm thinking that this is a typo. This should actually be a cube right here. There's no reason that should be actually a squared. So that should be a cube, which would make this a squared term, right? So let's factor as much as we can. So that factor by grouping would have worked then, but let's see what we have left over. So if I factor out x plus 2, we are left with x squared from this one, and then a minus 9 from this one. which this is now a difference of squares. This factors a little bit more, but let's just keep going. So we have that x, and then this is x, and we want the product to be 6, positive 6, and positive 5, so that'll be a plus 2 plus 3, right? And then this denominator here, this x, and then now let's try the factor by grouping on this one. So we would have x squared, and then x plus 3. And then if I factor out a minus 4, we will have an x plus 3. And this is x minus 3, x plus 2. So before I even simplify this, we probably could do a little bit of reduction. But you know what? Let's just finish it. So x plus 2. This is a difference of squares, so that's x plus 3, x minus 3. We have the x. We have x plus 2. We have x plus 3. So we have a lot of factors here. And we have x. We could factor the x plus 3 out. We're left with x squared minus 4, which is another difference of squares, x minus 3, and then x plus 2. Okay, now let's do some reduction. So let me switch to a red here, since there's a lot of factors. X plus 2, there is an x plus 2 here. X plus 3, there's an x plus 3 here. X minus 3, there's an x minus 3 here. An x, there is an x here. X plus 2, there will be an x plus 2 there, but since we didn't do that reduction yet, you know what? Just to avoid writing it out, what is this? This is actually x minus 2, x plus 2, right? So that x plus 2 will reduce that x plus 2, and we'll be left with the x minus 2 and the x plus 3. So in the end, we have x plus 3, and then that x minus 2 that's left over here.